Bonjour, good morning. Unfortunately, my French is, like most Americans, not very good, so I will be speaking in English today. I'm here to talk about something we at NGINX, I work for NGINX as their open source evangelist, we did to start looking at the impact of cloud-enabled, cloud-native modern applications. But to start with, let's talk about a little bit about what a modern application is. So a modern application, very honestly, has nothing to do with languages. If you want to write this in COBOL, feel free. But it includes certain things like being portable or scalable. You can observe it and reproduce it, make it debuggable. And in terms of observability, the space that I'm talking about here, the feature set includes things like finding performance bottlenecks, answering the performance questions that engineers may have, and as well finding areas on crashes and problems. So when we started looking at this, we said, let's take an existing production-capable Kubernetes-powered application and refit it for observability, and started looking at it from that. So the product set was like this. What we quickly found was the application was easy. It was all of the other things that were important to us inside of this. So we needed to be able to monitor what was going on, observe it. We wanted to be able to manage it. We had to run in a Kubernetes infrastructure to do this. And that meant certain things were challenging. If we were doing this purely as a demo environment, not using a production application, it actually turns out to be pretty easy. But what we really found out was that there were some observability challenges that came into play. First of all, this was a microservices-based application. It was written in multiple languages, in particular Python and Java for this one. We're actually working on one now that has 7 different languages that are involved here. Microservices create complex interactions. The communications are loosely coupled. And that means that things have to be watched not just from the application viewpoint, but from the communication viewpoint. We used NGINX open source load server and reverse proxy to manage a lot of those things here. The second thing is that in clouds, things are elastic. You can expand them and grow them, and things are ephemeral or they go away. So you can have serverless functionalities or even simply things being spun up and spun down. And that means when you go to look for the problem may not be there anymore, or it may not even be on the same system that you thought. That means that debugging becomes really a challenge in those two things. Failures don't exactly repeat. And the third thing, by the way, is that, especially in this environment, the scale of the data is enormous. The app here is not that big, but we did look at one when we were doing some of this work where they generate roughly 32 terabytes of log files every hour. And that's just the log files. That's not counting any of the other pieces here. So observability, where I'm faced is a data problem. And generally it breaks down into 3 classes of data here. Metrics. Do I have a problem? That's your alerting and structures for your dashboards. Traces, where is the problem? How do I find, where do I go look here? And then logs, what does the application think is happening? And when we look at these 3 pieces, they're often treated independently, with traces being the new member and what most people think of when we talk about telemetry. You probably have heard application performance monitoring. So we then said, what would we as DevOps really want to know when we got to the application space? And so we identified our short wish list, which started with logging, because we're all older engineers. We're used to log files, and that's where we deal with this. We decided we wanted to look at tracing, because tracing gave us some very discrete, independent information here. Metrics was a given. We also wanted to be able to look at error aggregation, how the errors were grouping themselves. We wanted to be able to run health checks against the application, and then runtime introspectives, and be able to look at core dumps. And then we identified a bunch of possible technologies. One person had worked with Elastic, so it's where we started. We looked at Grafana with Loki, Graylog. You can read the list. But when we looked down this thing, there were a couple of things. nobody quite did what we really wanted it to do. We wanted it to be a 100% open source solution. And some of the pieces seem to be better fits than other pieces. But we actually did know one thing. The products that we were working with had already been written for open tracing partially. So we said, oh, the heck with it, we're starting with open tracing. And what we quickly found was that when we went to the open tracing site, the first thing open tracing said was, the project's been archived. Go to OpenTelemetry. And so we said, well, Open Census, we've done work with Open Census. Same thing. Open Census, go take a look at what's going on with OpenTelemetry. And so we went to OpenTelemetry. For the short version of this, OpenTelemetry is a standards-based observability platform. It supports all of 3 of those data classes, some better than others, as we found out here. It has an agent capability called the collector. The collector is amazing, absolutely amazing. It has some automated code instrumentation, so you can do auto instrumentation of certain code bases. It has developer framework support, pretty much any code, anytime. And we could retrofit from Open Tracing to Open Census, use that code, and pull it into OpenTelemetry. When we got farther into this, we decided that was not going to work for us because we wanted to be able to keep with the future and not just to keep supporting an older technology from the past. Now, OpenTelemetry actually does do this. And when we looked at this from a telemetry viewpoint, we also rapidly realized there were certain things that we needed to make sure were in place in this decision. So instrumentation, we didn't want to have to hand code every single piece of things. So we needed an API that supported that. We wanted the canonical representations or implementations so that we could simply pull pieces in as we needed for this. We wanted data collection, the infrastructure piece that would pull the data in place. No one in their right mind should write their own agent from scratch. And then we wanted to make it standards-based. And so W3C trace context here, a standardized wire format for actually doing the telemetry work. All these pieces were part of what's in OpenTelemetry. And that gave us an easy way to basically say, okay, OTel, OpenTelemetry, was the right answer. Now, if you remember, we started with logs on our first list, so that's where we're going to start with logs. All of us probably know what a log file is. Basically, it's something that the application writes off and tells us what it thinks is going on. And that log can be a system log, syslog. It could be a third-party log, such as looking at an Oracle database or MySQL database. They write off those. It can be a first-party log, the application itself, and what you put into your code. Logs are really great, very simple to understand, and then you start getting into some interesting characteristics. It's easy to grab the log files and put them where you want to. It's complicated to transport them cleanly and correctly and keep times stamps equal. Even using NTP, Networking Transport Protocol, you can have a variance of 100 milliseconds in the best case from system to system in a cloud environment. And that's, I think Google's cloud has a special capability that can keep it within 100 milliseconds. It means that things can overlap in weird ways here. Storage, I mentioned my 32 terabyte capability. Storage is always an issue, especially when I was moving things to a cloud for this. Do I index or not index? Because the larger the information set, the more time you spend on indexing. It may help you on searching, but maybe not. And then how long do I keep them? If I'm looking at logs for security purposes, forever is the right answer. Most people keep them from somewhere 2 to 5 years. If I'm looking at debugging, I've got an error and I want to see what happened and caused that crash, 10 minutes may be the right answer. So somewhere in between those things here. We also wanted to make sure that we were completely searchable on any criteria, not just an indexed criteria. Because in observability, we're looking at things we don't know could happen, and we don't know that could happen until they happened. So we need to be able to go back and retrofit. So using the OpenTelemetry basis, what we wanted was this really cool little graph over here that basically said, okay, we're going to take the logs, the logging SDK, we're running it into the collector, and it goes to the back end. That doesn't work yet. It's getting close. It's getting closer. What we ended up doing was sort of the second thing. So it's going, okay, so we'll take the logs from where they exist, and then we'll pull them directly into our back end. And we skipped the OpenTelemetry collector. This is one of the things that we are in the process of changing. The OTel collector now supports Stanza as a logging construct. And so we can pull logs into it in its beta format. Logging is not stable. So we did start with Elastic Stack. We used FileBeat, we used Bitnami, and we used Kibana because of certain features. Kibana actually started us because we wanted to be able to search, and it had all these really cool preloaded things here. What we found was it worked, but it was massively resource hungry. It actually upped our CPU count necessary to run the application space, run this analysis space here by almost 50%. So that became a real bit of a headache here. And what we found was that searching for things inside the log files was, had different timings. And sometimes they would be really quick, and sometimes they would be really slow. And if you ask a question of your log system, you'd like to get an answer before you forget why you asked the question. So that became one of those things. This is something that we are definitely looking at improving and changing. Metrics, we went with Prometheus. So we deployed it via Helm. OpenTelemetry can pull Prometheus into its structure and handle it in the collector. So Prometheus can feed into OTLP. We had some nice clean operators. The headache is that OpenTelemetry is written as a streaming protocol. Prometheus is written as a scrape protocol, a pull protocol. And so we ended up having to build a service monitor. Fortunately, they mostly exist. That goes out and grabs it on a regular basis and pulls the metrics into play. Once again, we want to keep those aligned here. So we wanted to make sure that they stayed in place so that the metrics we were seeing matched to the logs we were seeing. And that became a bit of a challenge, which I'll get to. So distributed tracing. So distributed tracing is sort of the new space. And it looks at a single request going through a system. So each request, in its sense, is its own trace. The trace that's going through the system can vary in length of time, number of crosses. You can look at the endpoints. So it goes from microservice to microservice. You can just measure that piece. You can measure inside of the application. And all these pieces become a part of that overall trace here. It can be very complex. There's all sorts of pieces. Every trace is uniquely identified. Every span has to be in the right order and know who its parent was and has to terminate at the right time. You have to terminate it. There is no set termination that's built in here. We also wanted to make a couple of things happen. We did not want to have the quality of service interrupted inside of here. The collector is what we use to do this, and because it had some really nice features, once we got into the collector, we could pretty much go anywhere we wanted to. So we had the applications in Java and Python. We used a framework, Spring Boot and Flask, and we had multiple services that could scale up and scale down. We fed those into the collector, and we fed them off originally into Jaeger. And so this is what one of our traces looks like. Normally I do a demo, but I don't have that much time here. And so you can see the parent at the top up here, and then each application activity as it scales down. If you clicked on one of those bars, it will show you the underlying infrastructure and show you the underlying context around that specific functionality. And so you can quickly identify bottlenecks. You can quickly identify the errors that showed up in here. Now, when we started looking at this, we could now tell that the client library, just by looking at the trace, I can tell you the client library itself is not written for tracing. The HTTP client library did not have tracing involved in here. It doesn't hurt because I can actually see what the length of time was. But now I could go start adding observability. The OpenTelemetry gives you a place to start without having to have a perfect product at the other end. So it's all about the languages. Python was pretty easy. We added two instrumented API files to this. We updated the requirements.txt to include its dependencies. and we were done. Now, that was kind of nice because most of our user front end is where our Python code lived. And so we got a view from the user viewpoint. When we got to Java, on the other hand, life was a little more challenging. We found out that if you were just writing straight Java or greenfield application from scratch, it wasn't too bad. You just pull the libraries in, you use the APIs, and you're pretty much done. And when our framework, Spring, we thought it was going to look pretty easy here. Cloud Sleuth allows you to add these traces, has all the pieces in place here. It instruments the ingress points for here, and it can generate traces directly. But what we found was, and this has changed a little bit, but not as much as we would like, is autoconfig for Spring Sleuth was what they call a milestone release, and it was tied to a specific version of the OTel libraries, which was version 0.11, and we were at version 0.14. So when we did this, we then had to pull these things, we had to retrofit back, we didn't have enough time to write this thing to go up to 1.4. So what we did instead, we wrote a common module. This is all available in open source under NGINX Inc. You'll find this thing we call unsupported modules, which is where we use a lot of our sandboxing things here. So we built a module that would take the Spring-enabled classes and add the trace resources that were important for here. We also built a no-op version of this so we could turn it all off without having to take the code out, so we could measure the performance impact between those two. And then we added specific functionality to tie logs and traces together. If you remember, I had to loop around with my logs. We added in our telemetry module the ability that a trace would add the trace ID to the log files as they were being generated. And that gave us some really nice things that let us tie this together so we could look at all the pieces across the board. We also built an Apache version of this, and you can find that as well for this, just because, again, we wanted to show that this would work across many different capabilities. So we skipped Python on metrics, very honestly here. Java required some decisions. The original code sets we looked at were using micrometer, Stackdriver, the Google side of this. We found out there were some serious limitations with the JVM for metrics and OTel, but micrometer seemed like to be a pretty cool thing. And so we found the Open Collector could use everything. It didn't care. And so we pulled it all in. The micrometer pieces, the OTel collectors, the JVM pieces all fit into our collector, and then we could feed it off to Grafana, we could feed it off to Lightstep. It didn't matter anymore. So some final challenges to go about here. Understanding what libraries to use was a challenge. It probably took us a lot longer than we thought to figure out which libraries made sense for this. Auto instrumentation was a really cool concept. Too bad it didn't tell us any useful information. It gave us pretty traces, but the information the auto instrumentation gave us was not useful from our point. Setting up the collector, once we got it set up, was genius, and we would not have done this without that. And then finally, getting everything to reconcile so we could see a clean view of everything was also a challenge. What's next? We're doing load and performance testing right now. We've seen very little impact from adding telemetry to this. We are adding the log changes as they occur. We're really hoping that the data format goes stable in the next few months for this. And then we're taking and adding OpenTelemetry to other NGINX open source projects, of which right now there are 111 for that. So metrics, traces, and logs. It took all different approaches to get to what we wanted. And without the OpenTelemetry collector, it wouldn't have happened at all. We had some interesting gotchas when we looked at metrics and traces, partially driven by languages choices and partially driven by framework choices. What I've just talked about is a snapshot in time. We're continually updating this. We're actually taking on a more advanced project to look at additional language structures here. And then finally, the caveat. Auto instrumentation works great, produces things when you want them, but will it give you what you want is a challenge that you have to look at each time. And with that, thanks for listening to me today, and that's my LinkedIn connection information if you have questions, because I am out of time.
Yes, thank you, Dave. Actually, we have a 5-minute questions. We can just you can ask all your questions. Do you have any questions?
So you mentioned that Elasticsearch was very CPU intensive. So you said that Elasticsearch is very CPU intensive. Did you keep the solution? And
part of it is indexing. When you start feeding more and more information, I probably should get back to the microphone. Sorry. I think the question was our resource intensive nature. Part of that was indexing. Part of it is that it turns out that the pipeline is easy to establish, but actually turned out to be resource intensive when we were trying to gather things from lots of different pieces. If you had if it was all single application code block, it's pretty efficient. But in this case, when this application scales up, there can be somewhere between 60 to 90 front-end pieces working and 90 to 120 back-end pieces working. So I could have 210 individual applications running with, I can't even count the number of potential interconnects. I'm also tracking the underlying structure. If I was in a service mesh, I'd be looking at what the service mesh is doing. Here I'm looking at what NGINX itself is doing with the NGINX hotel module. And I'm tracking communication aspects, and I'm tracking the infrastructure. And honestly, we have not seen a good open source answer to this. There are two companies, unfortunately both of which were purchased by other companies, who had the ability to keep up with the volume of logs that we could produce. One is Scalyr, S-C-A-L-Y-R. I've forgotten who that owns them. And the other one is Humio, H-U-M-I-O. And both of those two would be able to handle this, but neither one of them is open source. And so we were limiting ourselves to open source releases.
Any other question?
Cool.
Thank you, Dave.
Thank you.
Prochaine